Greetings everyone, my name is Dr. Pavel Krastev and I'm based out of New Hyde Park, New York. On behalf of Helmut, Zepf and myself, I'd like to welcome you, ladies and gentlemen from all over the world, and we'd like to thank you for taking time out of your busy schedules to join us today for this presentation. We hope that you enjoy it and that you walk away with an additional tool that you may use in your future surgeries. So the VGO, manufactured and designed by Helmut Zepf, is a passive deep dilation system. And the reason we call it passive is because of the type of engagement that the instruments have with the osteotomies. And you will realize after this presentation that the way the system works is it dilates the deep bone, then the crestal bone, the deep bone, then the crestal bone. And this is very in a huge advantage to all of us in the sense that we can treat the bone now more delicately and more gently. So once again, welcome, and we hope you enjoy. So I'm not sure how many of you have previously used Helmut Zepf products, or how many of you are familiar with the company, but I'm sure for those of you that are familiar, you have experienced the quality of workmanship and design that Helmut Zepf offers. And in my opinion, and I'm sure in the opinion of many others, Helmut Zepf is one of the top global producers of dental instruments, and they do it for us to practice in a better, safe fashion and to provide the utmost accurate service to our patients. So without further ado, I would love to just thank Helmut Zepf for making this possible. Without them, this project will have not been where we are today. So I'm very grateful, and thank you guys. Special thanks I'd like to express to the CEO of Mr. Patrick Zepf and Mr. Heinz Leben, as well as Nicole Specht. I've personally worked with them over the last 2 years in developing our products currently and the products that are currently under development. So very many thanks to all of you guys and to all the hardworking people in the company. I'm very grateful. So the VGO, or also known as the variable geometry osteotomes, is a passive wave dilation system. But why do we say it's passive and why do we call it a wave? It's a passive system because our osteotomes will enter the osteotomy passively without any resistance until to a certain point. In such a way, our osteotomes do not apply unnecessary pressure to the very thin crestal portion that in most cases is the thinnest portion that we have to deal with. So conventional osteotomes have a particular mathematical problem that we're going to see in a bit, that essentially has a situation where you're trying to fit an osteotome into an osteotomy that has a small cross-sectional diameter, much smaller, rather significantly smaller than the next osteotome to be used. And this becomes a problem because when you're trying to put something larger into a hole, let's call it for argument's sake, that is smaller, you end up crushing the bone, damaging it, and essentially for many of us it becomes a sort of a turn off to using osteotomes because of the excessive hammering and malleting that we have to do to accomplish anything. So this was a problem that was bothering me for many years, and hence I created this new formula for this improvement that we'll be discussing. So it's passive because each time a subsequent instrument enters the osteotomy, it enters it passively. Our instruments become active at the 8 millimeter mark. Okay, so that's why it's a passive system. Also, we call it a wave system because the way our tips work, we have two types of tips, delta 1 tips and delta 2 tips, and they work in complete opposites to each other and at complete opposite poles to each other. So essentially one tip will dilate the deeper bone, the next tip will dilate the surface bone, and so on and so on and so on. So for this matter, essentially the dilation is being done from deep to surface, from deep to surface, from deep to surface, and the tips are loaded progressively. So now we know why it's a passive system, and now we know why we call it a wave system. Dilation, we all know. We dilate the bone, we expand ridges, we split ridges. So that's why that's where the name comes from. So it's safer because of the nature of the system, in the very fact that it will damage the crestal bone much less than currently existing systems. And this, of course, will lead to better predictability. By using this passive entrance into the osteotomies, we're essentially being more gentle and more kind on the bone, and essentially the surgeries become done and accomplished with less trauma. And most certainly, whether we're working in the posterior or anterior, the malleting will be reduced. In the anterior, with our system, there is no malleting because the instruments are threaded. The first 8 millimeters are threaded, and this is, in essence, drives the instruments to working depths. All right. In the posterior, we have no choice. We have to resort to malleting because we have a limited range of rotational motion. So our angulated or offset osteotomes with a posterior kit have built in an angular component, two poles, and they're offset, as we all know. So there we have to mallet. However, the malleting is reduced because of the passive relationship to the osteotomies. We absolutely do not generate any heat with the system, and this I'd like to mention very, I'd like to underscore it or underline it or highlight it, whatever you want to call it. We're not generating any heat. And I think this is very important because regardless of irrigation or not irrigation, when you have rotation at decent speeds, rubbing against bone, you will create heat. All right. So this is one huge advantage of our system. Our system is also very flexible. As you will see, there's several options of use, which we'll talk about later. All right, let's go to the next one. I don't know how many of you have seen a show that we have in the United States called Shark Tank. And it's a wonderful show where different inventors bring their products and they talk to the sharks and hopefully get sponsored. But anyhow, one particular episode, Mr. Mark Cuban, who is one of the sharks, said something that really stuck with me for a very long time, and I decided to share it with all of you. And he said, there is no perfect product. And what this means, folks, is we cannot expect for one particular system or for one particular product to provide a solution for every scenario that we may encounter. So there is no magic products. All products that we use in dentistry and implantology, they all have limitations. And for us or any other company to claim that we or they have a special product that's one solution for all, I think is a fallacy. So we make no such claims with the variable geometry osteotomes. They are a system designed to be used for certain cases, for certain situations, and to hopefully give you guys another option at your fingertips of how to manage the bone and the osteotomies that we deal with on a daily basis with greater success. So let's have a look at some important points. For the anterior kit, there is absolutely no malleting involved. You typically start with a pilot hole of your choice of whatever system you're using, and then we will start with tip 0 and proceed all the way up to tip 6, or of course you stop anywhere at any point that is necessary for you. The initial 8 millimeters of our anterior kits are threaded. Okay, so the threads themselves will do several things. A, they will drive the instruments into the bone. B, they will make micro cuts into the bone so that as the next instruments come in, they will actually squash the bone that's already been pre-cut. You also, I'm sure all of you have seen or done cases where you do an osteotomy and you see no bleeding in it. Well, that's a no-no. We want bleeding, and we want all the good stuff that's contained within the blood to come out and be there when we place our implants. So the fact that we're threaded will cause microserrations in the bone, which will increase the bleeding, which will increase the extrusion and secretion of all the good stuff that's contained in the blood itself. And hence we have more success. We have more ingredients into the stew that we're making. All right, so the other big important thing that I'd like to mention, our kits are labeled, our tips have individual markings, which we'll go over as we proceed. But the important point to note is this: our kits can be used in 3 main modes. So the VGO or Zepf mode, or the new mode, is the way we feel is the best to use. The next best one is something called the hybrid mode, okay, which also has the benefits of passive insertion and is much safer than the traditional modalities of use. Now, another key factor is less stress to the crestal bone. As we all know, and I'm being a bit repetitive here, but there's certain points that I'd like to drive home really well today, so I will repeat them over and over. The crestal bone is typically our thinnest area, and that is the area that if we put too much stress on, we are inevitably going to damage it. Now, another thing that I think most of us have experienced when we do osteotomies with a handpiece and with a drill attached to the handpiece, there are many cases where angular control becomes an issue because of the length of the drill itself. It's relatively short compared to an osteotome. So whenever you're doing cases with our system, you have a beautifully designed instrument that is long enough that will provide you beautiful angular control that you could utilize the correct trajectory of exactly what you want to accomplish. Another very important point is that with our system, you have complete control of the rate of dilation. I repeat, the rate of dilation. So that means how fast we are dilating the bone. So in softer bone, generally it's easier and safer to proceed a little faster because soft bone is very flexible. So as you squash it and condense it or expand it or whichever procedure you're doing, the bone is more quickly to respond. If you're dealing with very dense bone, then you really want to expand slower, so you give the chance to the bone to expand. Otherwise, you are very likely to fracture a plate, and that is obviously not a result that we'd like to achieve. So in many cases, we all know in the maxilla we have soft bone, type 2, type 3, type 4. Now type 2, great, but what about once we start moving posteriorly? Usually type 3, type 4. So in most cases, when I do my cases, I like to densify the bone. I like to improve the quality of the bone. In some cases, you may say, well, it's a bit slower. Well, you know what? I will still rather take a bit longer and condense it, improve the quality, and that will give us longer and better success long term. The nature of the VGO system is such that even if an operator or the surgeon is not familiar with all the different modes and the different nuances of our product, the product will still work great. So a thorough understanding is not necessary to use the product. However, a thorough understanding is a must in order to understand all the benefits that we're going to offer to the public. So this is the key. This is why I encourage all of you to read this presentation, watch it, listen to it several times, so that the concept itself sinks in. Because then you will be able to fully benefit of all the uses that will become evident shortly. So if you look at the bottom of the screen, I have marked 3 areas so that I call the first one the Zepf mode, second is the hybrid mode, and the next one is traditional mode. So our sets of instruments or kits can be used in these 3 main modes. In our opinion, and in my opinion certainly, the Zepf mode is the safest and the best way to get the job done. The second best option is the hybrid mode, which also does a similar thing of expansion in a similar fashion. However, it does it slightly differently. And certainly for those of you that would like to use it as a traditional osteotome, all you have to do is omit certain tools of our kits out, which are clearly labeled, and then what is residually left is a conventional osteotome set. So there is no system in the world, folks, that will offer you this kind of flexibility of use. All right, now, so we have several modes. We mentioned that. Let's review a bit. We know that we have delta 1 and delta 2 tips. We also, let's look back and think the two tips, delta 1 and delta 2, work opposite to one another. So we have to also look at different bone densities. You know, how do we address one case in comparing to the next one? You know, one case may have different quality of bone. One case may have different amounts of bone. So we must be very specific to how we handle each individual case. The speed of dilation, this is again, I just mentioned it earlier, but I want to drive it home a little more. When we do an osteotomy with a motor-driven device or an electric handpiece, we hit the pedal, it pretty much runs the engine at the speed that's preset, and you're going in and out doing what you have to do. But you cannot really control the rate of how quickly you're doing it. All right. So with our system, it's completely up to you how fast or how slow you proceed. And this, of course, will allow you to address different bone densities with their different bone elastic values in a different fashion, suitable for that particular case. Ladies and gentlemen, myself, you guys in the audience, all of us dentists and surgeons and periodontists, and you know what we do, we work in a very small environment, in a very small space, and in that small space we work even in a tinier space, and sometimes we even work in there. So essentially what I'm saying is that all of us are in a way microscientists, as I like to think, and as such we work and we face situations that are very variable. So when we handle bone, and more specifically osteotomies, we have to think about how do we get this osteotomies done in a more atraumatic fashion? How do we manage the osteotomy for a greater success with our implants? So in my opinion, bone is something that I consider to be gold. To me, it's gold. So I always ask myself, how do I remove less of it? And how do I manage it that I hurt it less? And with this particular system, the VGO, we are exactly doing that. We're minimizing the trauma that we're creating onto the tissues that we're working on. So we'd like to think that for different situations, we're going to control what happens to that bone. We're not just going to go in and say, well, this is what we have, this is what we have, and settle for it, but we'll try to modify it to our advantage. So in essence, we work at the nano level of technology, and today we'll talk about the nano level of how we actually manage an osteotomy. Our osteotomy techniques should be selected based on the situation that we have currently at our hand. Bone can be very variable in width. We have different heights available. The densities can certainly vary from case to case. And then in different cases, we have different angulation relationships, angular relationships with teeth and bone. So we have to take that into consideration. We have different morphologies. We also have different mesiodistal spaces and spaces to deal with. What about buccolingual? So we must ask ourselves, how much bone do we have? And what do we want to do? What is our goal? What do we want to accomplish? And then the last question should be, how are we going to get there? How will we reach the end that we're trying to accomplish? And in my opinion, we must get there with the least amount of trauma that we will induce to the tissues. So in some cases, sure, we use rotary drills and we do what we need to do. In other cases, we may use osteotomes alone. But in some cases, you do combinations. So what I encourage all of you to do is to think sometimes not just like a cooking cutting approach. I do it always this way, 1, 2, 3, 1, 2, 3, 1, 2, 3. But sometimes ask yourselves, maybe in this case I should do it a little differently, because what would I benefit? So let's learn to think again with the old cliche, the old saying, we have to think outside the box. And let us always try to do what's most appropriate for each and individual patient that we treat. As I previously mentioned, we have to always ask ourselves, are we dealing with a case that has soft bone, intermediate bone, or dense bone? And once we realize that, which we very often do with the pilot drill, then we have to adjust and modify our technique to be such that it will be conducive for that situation. So I repeat, in soft bone, we can progress to expand or dilate faster because the bone is more responsive to move quicker. It's not resisting. In dense bone, we must proceed slower and with caution. All right? As you guys will see later on in the presentation, that delta 1 tips and delta 2 tips, they have different taper. So a delta 2 tip has twice the taper of a delta 1 tip, which again we'll cover later, but I'd like to mention it early on. So when you're using a delta 2 tip, you must know that you are essentially dilating the bone twice as fast as the previous instrument did. So you must use the delta 2 tips for this reason at a slower rate. And this, again, I repeat, is why you need to understand the system. Let us look at some brief definitions right now that I'm going to be referring during the rest of the presentation. So, as we can see on the left hand of the screen, we have, what looks like an osteotomy. So the deep area we're going to call the apex, or the apical area. And the crestal portion we're going to refer to as the base. So crestal bone, base, apical bone, deep bone, we'll call it apex. And with the osteotomes, of course, we'll look at the apex of the osteotome and we'll look at the base of the osteotome, which you can clearly see on the right side of the screen. At some points here and there, we may refer to the cross-sectional diameter of the instrument. We may refer to this diameter at the apex. We may refer to it at the base, or we may refer to it when it comes to the cross-sectional diameter in the middle of the instrument. Alrighty, let's move on. On this slide, I would like us to focus for a minute or two as to what areas are we really working in, what are our areas of biggest concern. So we all know the anatomy, and we know that distally and mesially to an osteotomy, there may be structures, there may be teeth, but usually there is bone in either direction, distally or mesially. But buccal and lingually is usually the areas that worry us, the areas that give us difficulty because of the limited available bone, buccal-lingually. So those are, the buccal and the lingual areas are the areas that are going to be the difficult ones to handle. So on the bottom here, let's read what it says. Let me read it for you. Although we encounter structures mesially and distally, our main focus will be at the buccal and lingual dimension. Generally, we would like to have at least 2 millimeters of bone around an implant body. Now let's talk about that for a minute. Regardless of what technique you're using, regardless of how you're doing your osteotomy, and regardless of what size implant you put, at the end of the day, you really should strive to have a minimum of 2 millimeters of bone to the buccal of that implant. If it's paper thin, folks, long term, it's probably going to have a problem. So regardless of osteotomes or no osteotomes, or drilling or not drilling, or how you get to the end of forming the osteotomy, you really should consider grafting if necessary additionally in order to create that minimal threshold of 2 millimeters of bone around your implant. So regardless of technique used, dilating the bone, additional grafting must be considered to accomplish this minimum requirement of 2 millimeters. Here we're looking at one of my favorite slides in this whole presentation because I feel it's probably one of the most important ones. Let's talk about it for a moment. So we have 3 columns of bone, A, B, and C. And what is the difference? Column A, we call it passive engagement. And what that means is the instrument freely goes into the osteotomy. It does not put any stress at the crestal portion, but it starts to dilate deeper inside than the crest. So it's a passive entrance, and this is how the Vgo system operates. So the Vgo system is passive engagement. So we're going to be talking about this constantly today. So passive engagement is option A, and this is how our system works. Let's look at column B now for a moment. I call that passive active engagement. And I think I've coined these words. If anyone else has coined them, I give my apologies, but I think I'm the first. So passive active engagement is what happens with conventional osteotomes, but when they are used to the full working depth of the working tip. So if an osteotome set has 8 tips and the maximum working portion is up to 16 millimeters, let's say. So when you use the first instrument, then the second instrument, if you're using them to full depth, then you have this kind of relationship shown in the middle of the screen called passive active engagement. Now, as we can all see, this is okay, but this type of engagement starts to load the crest immediately at the crest. Not deeper inside, but the pressure starts to be applied instantly at the crest. So, again, this works, but it works when you're using the full length of the full working portion of each successive osteotome. Once you start going to less than full depth, so for example, on a 16 millimeter maximum osteotome, if we're going to place a 10 millimeter implant, so now you're taking each osteotome to 10 millimeters. And when you're doing that, the subsequent instrument starts to have the kind of relationship you see on the right side of the screen labeled C. That I call non-engagement. And it's essentially exactly what I mentioned in the beginning of the presentation. That this kind of relationship now, you're trying to get something bigger with a larger cross-sectional diameter. You're trying to force it into a hole which is smaller with a smaller cross-sectional diameter. And you folks can obviously, I think, agree with me that this starts to cause a crushing kind of motion. It starts to break away at the crest. And as we all know, that's the thinnest and the weakest portion. That's the portion that we have to be most cautious with. So we must ask ourselves, is this acceptable? So let's review a bit. Conventional osteotomes that have linear taper, if they are used to the full depth, we have a relationship shown in B, passive active engagement. So the instrument starts to work instantly when it touches the crest. That will work only for full depth. The minute you start working at a distance less than the full working tip, then you start to encounter problem C, non-engagement. And that, folks, in my opinion, is not acceptable. And this is what we're trying to avoid. This is what we have changed. And now we're strictly functioning on the basis of the left side of the screen called passive engagement. The instruments go in passively into the osteotomies. Let us now take a look at a little bit more detail for the three different types of engagement. So once again, they are passive engagement, passive active engagement, and non-engagement. So in passive active engagement, let's focus on those red dots that we see on the screen on the left side for time being. Passive engagement, the instrument will start working and start dilating the bone deeper within. So when you start doing that, you're moving the axis of rotation further into the deeper bone, and you're hinging it from a deeper portion. All right. The other thing that's going on is, as the subsequent osteotomes of the VGO system go inside, they are thinning the bone, and in essence, once you make the walls thinner, they become more flexible. So this is the best alternative on the left side, passive engagement. Passive active engagement, as I previously said, causes instant application of force on the crest. And let's look at the red dots where they are there. They are right, so you're trying to spread the bone instantly in the thinnest portion, as opposed to doing it from deeper within. Again, this works with limited success, and you start running into a problem when you're not using the full length of conventional osteotomes. That's when you run into the right side of the screen called non-engagement, folks. And that's, as I have marked it in red, no, no, no. Why? Because it causes crush-stroke crushing. It's vertically compressing the bone without spreading, it's simply crushing. And that we must avoid at all costs. So let's look at some definitions. Passive engagement is the most desirable way for us to accomplish this dilation. It puts the least amount of stress on the crestal bone. Passive active engagement is desirable, it can work, but there's limitations. And this will certainly stress the crestal bone more than the above known as passive engagement. At the bottom we see non-engagement. Not desirable at all, folks. This will damage the crestal bone. So we must avoid non-engagement. When a traditional Summers osteotome is used to full working depth of instrument, the next tip will engage previously made hole passively and will start being active immediately as it progresses further into the bone. So we call this passive active engagement. So passive active engagement, successive osteotome can enter hole passively but immediately starts to spread the bone. So the tool or instrument immediately becomes active. When a traditional Summers osteotome is not used to full working depth of instrument, as is the case when you are doing an implant shorter than full working portion of tip, then the succeeding osteotome will not fit into the previously made hole due to an inadequate cross-sectional diameter created by the previous osteotome. So we call this non-engagement. So once again, non-engagement is when the next osteotome is used, it simply does not fit the hole created by the previous instrument. This is what occurs when the traditional Summers osteotome are used to partial depth of the tips. When non-engagement occurs with successive tips, the crestal bone will be crushed, since this simply cannot fit into a hole with a smaller cross-sectional diameter than the tip apex which is now being used. Passive engagement, successive osteotome fits freely into the previous hole and becomes active at a point deeper than the crestal bone, as is currently done by our new system. So let's review one more time. Passive engagement. The new Zepf way works passively for all depths of the tip until you reach the 8 mm threshold. If tip is only utilized to make an 8 mm hole only, then passive active engagement starts to occur. With the new Zepf way, at any point, both desirable options are inherently used. So you will never face crushing and damaging the bone in the range of 8 mm to 16 mm. Passive active engagement, on the other hand, is the traditional approach. So the traditional approach works like this when working to full depth of the tip. When you don't work to the full depth of the tip, then passive active engagement becomes non-engagement, as I previously showed you. So this is the pitfall of traditional approach. This is the pitfall of the traditional osteotomes. Namely, when you are not utilizing the full working depth of the tip, the successive tip will be non-engaging and will not fit into the osteotomy. This in turn is what damages the bone. So I know I'm very well aware, guys, that I'm being very repetitive here, but this is a very important point that I need all of you to fully understand. And that's why I'm saying it probably 3 different ways and with the same point I'm trying to drive across. So non-engagement finally. So this occurs immediately when doing the traditional approach, where the tip is used shorter than full depth. The next tool will not fit in the osteotomy. Successive tool apex diameter is the same as previous tool base diameter at full depth. Since we are using tool to less than full depth, the cross-sectional diameter of the osteotomy achieved cannot accommodate the next tool cross-sectional apical diameter. Crushing of the crestal bone will thus occur. So let us now look at, for a few minutes, the difference between using the osteotomes the Zepf way, the new way, the VGO way, compared to the traditional way. Now, but when we talk about the traditional way, we again have to ask ourselves, do we use the full length of the working portion of the tips, or are we using less than half, or less than the full length of the working tip? And that's where the difference is. So let's start on the upper left side, and the Zepf new way, I say, is best and unlimited because to all osteotomy depths as short as 8 millimeters, you have passive engagement. Once you start doing osteotomies less than 8 millimeters, it becomes passive active engagement. And yet, this is only true for 50% of the instruments when you are less than 8 millimeters. In the traditional approach, again, we have either full working portion of the tip or less than the full working portion of the tip. So the middle, the traditional approach that is labeled OK and limited, is labeled in such a way because when using the full tip length of an osteotome, you do have passive active engagement, which remains as passive active engagement. All right, but when you're working to less than the full tip length of a traditional osteotome, then again passive active engagement starts to become non-engagement. So let's review. Passive engagement gives minimal to no crestal stress since the axis of rotation is moved away from the crest and deep into the bone. Deep bone has been made more flexible and now conducive to being expanded. This is the most gentle way to manipulate the bone, in my opinion, folks. Passive active engagement, on the other hand, will stress the crestal area much more so, since the hinge axis is closer to the crest and not as deep as it occurs with the Zepf VGO way. And non-engagement is something that, I repeat, we must avoid at all costs. Okay, this will crush and damage the bone. So non-engagement is something that we must avoid at all costs, okay, because non-engagement will cause damage. It leads to excessive hammering, which is certainly not desirable. It is not comfortable for our patients, and most patients don't appreciate when you use the mallet too much. In addition, we can cause vertigo. Vertigo is usually transient in nature and spontaneously normally resolves, but it is still a side effect that we really want to minimize occurring and possibly to avoid in situations that we can. Furthermore, with excessive hammering, and non-engagement, we can fracture the buccal plate very easily. And that's something we do not want to do. So with the Vgo, hammering is minimized because in the anterior, we're not hammering, okay? In the posterior, we have angulated tips because of the limited range of motion. So yes, we are using a mallet. However, the malleting will be less because we are again passively engaging the osteotomies. So here I'd like to focus our attention on the types of tip escalation that occurs in the Vgo system when compared to the traditional osteotomes. So with the Vgo system, we are using a stepped formula for tip escalation, and this is in fact what allows us to have the overlapping escalation of each tip. And this, folks, is what makes the dilation occur in the manner that it does. Now with traditional osteotomes, we have a linear tip escalation, and this is a non-overlapping escalation. And the limitation with the non-overlapping escalation is that when you are using them, half the maximum of the tip, excuse me, not half, I keep saying half, pardon me folks. When you're using less than half, less than the full working tip portion, it starts to become a problem, that leads to non-engagement. So let us begin our focus and evaluation of standard or traditional osteotomes, as I call them. Let us have a look at what they do or what they don't do, and let's look at how we have improved them. So in a very basic form, a traditional osteotome is nothing more than a tapered cylinder which has linear taper, and then we chop off into equidistant pieces the cylinder. We apply handles onto these pieces, and essentially we have a traditional osteotome set, which was originally published in the 90s, I believe, by Robert B. Summers. So Dr. Summers did a lot of good things for us, folks. So in a traditional osteotome kit, let us look at the tip relationships. So typically what happens is where the apex of one instrument begins and ends, the following instrument will have the apex be the same diameter as the base of the previous instrument. And then so forth and so forth, it continues. So once again, where the base of one instrument ends, the apex of the next instrument begins. So let us read the bottom of the definition. So the base diameter of each instrument has same diameter as the apex diameter of the next tool or instrument. To say it differently, the apex of each tool has the same diameter as the base of the previous tool. With a standard osteotome, as I said previously, we utilize a linear tip escalation. And what that means is that as the tip apex is increasing, the tip base is increasing. So we have no steps here. It's simply a linear escalation of both the apex and base of the instruments in question. So in this situation, we see that the full working portion of the tip is 16 millimeters. The first instrument, labeled number 1, we have an apex of 1 and we have a base of 2.0. So the next instrument that follows will have an apex of 2.0 and a base of 3.0. And as you guys can see very clearly here, if you make an osteotomy that's the full 16 millimeters of length, the cross-sectional diameter that's residually left at the crest will be 2.0 millimeters. The next instrument will come in and will have an apical diameter of 2.0. So again, this will immediately start binding at the crest and start displacing the crest right with the thinnest and the weakest. So let us again take a look at a traditional osteotome and just break it down a little further. So we have 1.0 diameter at the apex, 2.0 at the base, full length of working portion of the tip is 16. So in the middle, which would be at the 8 millimeter level, the cross-sectional diameter will be 1.5 millimeters. At the base of the instrument, the cross-sectional diameter will be 2.0 millimeters. So 16 millimeters is full length of the active tip portion. At 16 millimeters, the cross-sectional diameter is equal to 2.0 millimeters. And at 8 millimeters, the cross-sectional diameter is 1.5 millimeters. So here we're once again clearly seeing what occurs when you go from instrument 1 with a traditional system to instrument 2 with a traditional system. And we have it labeled here just as this is sort of a repeat of the, I believe, second slide before this one. Anyway, full lengthening portion 16. Cross-sectional diameter in between the full working portion is 1.5 in case 1 here, the first tip. Cross-sectional diameter for the second instrument will be 2.5. And again, let's look at the relationship. When using the full length with the first instrument, you have passive-active engagement, as previously I explained. So here we're looking at, again, tip number 1 of a traditional osteotome system. And I am just going to show how if you use this instrument to the full portion, the full working portion of 16 millimeters, it will leave a residual osteotomy that has a apical diameter of 1.0 and a base diameter of 2.0. And once again, we used it to we went from the crest 16 millimeters into the osteotomy, so we used the full maximum working tip portion. And this, once again, folks, will assure for the next instrument to have the passive active engagement, which once again means that the instrument, the following or subsequent instrument, will start working immediately at the thin crestal portion. So let us now focus what happens when a traditional osteotome kit is used to less than the full depth of working tip portion. So as we can see here, let's assume that we're making an osteotomy that's only 8 millimeters deep. So we're working only half of 16, which is up to here. So we use the first instrument and we get it into the osteotomy, and we end up with a hole that's 1.0 and 1.5 because we're only going to 8. So now the subsequent instrument comes in, but the apex of the subsequent instrument has a 2.0 apical diameter. So now you're trying to put something that's 2.0 into something that's 1.5. And that, my friends, is non-engagement, and that is something that we need to seriously consider staying away from. So once again, here we're just showing a different diagram of pretty much the same thing we just said. If you are working to only 8 millimeter depth, you're leaving a residual osteotomy which has 1.0 and 1.5. And when you take your next instrument, which would be instrument 2, and you try to put it in here, again you're trying to put in something that's 2.0 diameter into a hole here which is only 1.5 millimeters. Again, this is the exact concept that I'm trying to get across, called non-engagement. Again, this is something that we like to avoid. So this is an interesting slide. It kind of repeats again the same thing that I've been saying over the last few slides. So once again, passive engagement is something that we desire, creates the least stress. And here what we're showing is essentially what happens if you use a standard osteotome to the full tip length, and what happens if you use the same standard osteotome to less than the full tip length on the bottom right of the screen. And as you guys can see, when you are using the full tip length, throughout the expansion you have this type of relationship, namely passive active engagement, which is okay. The minute you start using less than the full tip length, we have the bottom right corner of the slide marked in red, where you are starting to go into the non-engagement type relationship. All right, and that occurs from the beginning of the procedure to the end. When using less than the full length of the working portion, I repeat, you have non-engagement and you have crestal destruction. Again, not a desirable outcome, and even not a desirable method of getting the expansion done in. So let's review one final time. When we're using standard osteotomes to full depth on the left side of the screen, and when we use standard osteotomes to less than full depth. So we show what happens. In case 1, when we go full depth, we have passive active engagement, okay to do. In the other side, when we do less than full tip length, such as here shown at 8 millimeters of an osteotomy we're doing, then you're trying to essentially put something bigger into a smaller hole, shown right here on the right side of your screen. Okay, so this does not work and we should not try to use it. Okay. And in this slide, if we focus basically just on the relationship right here on the left side where the osteotome is entering the bone, we're seeing again, when working to full depth, you have the passive active engagement, and when you're doing less than that, less than the full depth, then you start to have the non-engagement. Once again, here it's graphically illustrated pretty nicely. And if you look at the numbers, you can go over them and realize that essentially you're trying to put on the left side of the screen, you're putting something of the same diameter into the same size hole. In the other side, on the right side here, then we're trying to squeeze in an osteotome with a tip that's bigger or bigger in cross-sectional diameter than the osteotomy that we're working in, and that doesn't work, folks. At this point, I'd like to focus on the actual kit. So let's take a look at the VGO and what the kits are made up of, and we'll go over the different tips in detail. Okay. So here we're looking at the VGO kits, and we have an anterior kit and we have a posterior kit. If you guys focus on top of the screen for a moment, you will notice that we have 7 tips for the VGO anterior kit, and for the posterior kit we have 8 tips. The reason we incorporate 1 extra tip in the posterior kit is because we deal with wider ridges in the back usually, and we need to be able to allow ourselves to place wider diameter implants. So therefore we have provided you with tips that can accommodate from a very narrow implant to a very wide implant. In the anterior kit we feature a threaded first 8 millimeters of each tip, and we have 7 tips. For the anterior kit, we start from the labeling is done in a little bit of a original manner, and there's rationale behind it which I will explain. But in the anterior we deal with very thin ridges, so we have a tip called tip 0. So tip 0 is the initial tip, and it's very, very thin to accommodate the fact that we very often face very thin ridges in the anterior. So the particular tip called tip 0 and its size dimensions, they are skipped in the posterior kit. So the posterior kit starts with 1 instrument larger size. Both kits, anterior and posterior, feature the Helmut Zepf designed special handle with a crossbar member that's removable, and you can use it or not use it, up to your choice. I personally utilize it almost every time. It really helps me to rotate the instrument very often with 2 fingers. Okay, so let's go to the next slide, and we'll start looking at the greater detail. So the anterior kit of the VGO system consists of instruments numbered 0 through 6. These instruments are partially threaded to the 8 millimeter point. The posterior kit, on the other hand, is made up of instruments numbers 1 through 8, and they are non-threaded. So let us focus on some of the benefits and things that the anterior kits offer. So once again, the instruments are numbered in the anterior kit from 0 through 6. And let's look at some points now that are pretty important. The tips have the first 8 millimeters threaded. So this essentially will drive the instrument into the bone. Another benefit is that the threads produce micro cuts in the bone, and this in effect causes more bleeding and better angiogenesis, and all the good components that we find in the bone, in the blood rather, will come out. No malleting will be necessary in most cases as far as we foresee. Now, addition of tip 0. So tip 0 is unique to the anterior kit. So tip 0, which has apical diameter of 1 millimeter and base diameter of 2 millimeters, is unique and only is found in the anterior kit. So tip 0 is introduced into the anterior kit to accommodate the very thin anterior ridges that we often find. Tip 0 is unique in the straight kit we mentioned that provides, okay, now that's another good point. So both kits provide a precision marking tip, and these precision marking tips are two of them. We have a straight one and we have an angled one, and they're very, very useful when you would like to mark your initial starting point, or if you want to re-angulate, or when you're doing immediate placement. And very often when we do immediate placement, the drill starts to slide inside the lingual wall that we're in most cases trying to engage, and does not want to follow the path. So now with these very precision tips, we can utilize them to mark the initial points where the osteotomy will be initiated. Posterior kit, on the other hand, is made up of instruments 1 through 8. And here the first instrument, instrument number 1, is a little bit bigger. It has the 1.0, 3.0 taper. So we're starting here with a larger tip in comparison to the anterior kit. And we're doing this for the reason that in the posterior we generally will have more width to work with. No threads, since the motion in the posterior is limited and we really have no ability to rotate. Now, one benefit of the posterior kit is that we have placed the initial marking on the osteotomes at the 5 millimeter mark. And as we all know, 5 millimeters is the usual threshold most people like to observe, which differentiates between doing a Krastev elevation and a lateral window sinus elevation. So most of us feel comfortable that 5 millimeters will work, and that's kind of the reason why we have decided to place that 5 millimeter mark. So it's very convenient for all of you guys and gals in the audience that we use the system. So we have a total of 8 tips in the posterior, numbered from 1 through 8. And the tips have the exact same taper as the tips found in the anterior kit. Once again, we have 2 additional tips labeled 7 and 8 to accommodate wider ridges typically found in the posterior. So I guess all of your friends here in the audience have heard the terminology in reference to real estate, that in real estate everything is location, location, location. Well, with the VGO system, it's all about flexibility, flexibility, flexibility. So the VGO kit consists of an anterior kit and a posterior kit, and each of those kits can function in one of 3 modes. The most recommended mode is the Zepf VGO mode. The second most recommended mode, which also features passive insertion, is the hybrid mode. And lastly, for those of you that wish to utilize the VGO kit in a fully conventional manner, like a conventional osteotome with a conventional taper, we offer you the standard mode. And as you will see later in the presentation, the standard mode of use can be broken down into many submodes, which essentially allow you to control the dilation rate and to address different qualities of bone from soft to less soft, and this allows you to have tremendous flexibility as to how fast you proceed in each individual case. Now let us look at some of the features of a standard kit, and let's compare that to some of the features on the VGO kit. So a standard kit is limited, may hurt the bone, only one option of use is offered, you have less control and less areas to less ways you can choose from to utilize. You cannot specifically address different bone situations and densities, okay, because you're using one taper. You will crush the crest of bone when not using the full length of the working portion of the osteotome. Does not enter the bone passively. And if you are using such a kit, you will have to mallet more. The VGO kit, on the other hand, is much more gentle on the bone. We offer much greater control. We offer you various modes of use. And you can focus on different bone densities in different situations. You can also dilate at different rates of dilation. So you decide you want to be more aggressive, the way you may consider in softer bone, or do you want to go slower and do the dilation over additional tips? And you will not crush the crest of bone. This is a key. Okay. Always enters the bone passively. And for these reasons, you have reduced malleting, with malleting being fully eliminated in the anterior kit. And this, of course, translates into less potential negative effects such as vertigo. So each kit is equipped with two handles. We have, as I previously mentioned, the crossbar member, which is removable only by pushing it in. It locks in beautifully. And each kit comes with both of these. Right, so this is very convenient. So while you use one tip, your assistant can place the second tip for you, and vice versa. You pass them back and forth. It's much easier. What I typically do when I do surgery, I take out all four handles from both kits, anterior and posterior, and I essentially put the first four tips in four different handles. So this way I stop less often, or my assistant doesn't have to be preoccupied with changing tips. Everything is sort of ready, at least to that diameter. Now, if you guys focus on the right side of the screen, I'd like to mention that the chucks that hold the tips are fully lockable. The handles are beautifully and ergonomically designed to be extremely comfortable for use. And the cross member I mentioned is detachable. And another thing that I'd like to mention, my friends, is Helmut Zepf machines and finishes all their instruments with such beauty that, in my opinion, they're just gorgeous to look at. And I personally really love to enjoy the highest quality that all of their instruments offer. So once again, here we're seeing the anterior kit, all the tips. As we can see, the tips are threaded to 8 millimeters. All the tips have markings at 8 millimeters, which is the end of the thread. Then we have the second marking at 10 millimeters. The next marking is at 13. The next and last marking is at 16 millimeters for all of the tips. We have other demarcations here, which essentially show you the taper of each individual instrument. So the first instrument of the anterior kit is called tip 0, which you see on the bottom left here. It's labeled as 0. The next tip is 1, 2, 3, 4, 5, and 6. Okay, so let's look at tip 0 for 1 second in the upper left corner of the screen. That has taper of 1, millimeter, 2 millimeters. The next instrument, which is tip 1, has taper of 1 millimeters and 3 millimeters. The next one has 2 millimeters, 3 millimeters. The next one 2 millimeters, 4 millimeters. The next one 3 millimeters, 4 millimeters. The following is 3 millimeters, 5 millimeters. And the last one is 4 millimeters, 5 millimeters. And here we just show a little bit of a magnified view of the anterior tips. Once again, we have a beautiful symbol here between the demarcations, which lets you know whether the number in question is the apex or the base because of the shape here we've incorporated. So again, 1, 2, we have a 1, 3, we have a 2, 3, we have a 2, 4, a 3, 4, a 3, 5, and a 4, 5. Okay, and we have nice convex shapes at the tips, so that whenever you are encroaching next to important structures, the instruments will not necessarily be very sharp. The next area that I would like to discuss is again that has to do with the markings. And again, we have tip 0, 1, 2, 3, 4, 5, and 6. And if you guys focus on the first tip here on the left side of the screen, this is tip 0. The reason we have 2 dots above and below the 0 is because this tip will initiate the osteotomy, following the pilot hole, of course. And because this tip will initiate the dilation process, we assume that this is a fully active tip. The other reason is many of you will utilize these kits with various implant systems that have various diameter pilot holes. So for this reason, tip 0 is an exceptional tip in terms of the way it's marked, and we have the delta dots, as we call them, above and below, which indicate that this will be a fully active tip. The next tip, if you look at tip number 1, has the dot below the 1, and what that means is that this is a delta 2 tip. The next one has the dot above. Okay, this is a delta 1 tip. The next one has the dot again below the number, so this is a delta 2 tip. And what this delta demarcations and explanations will mean to you, we'll discuss in a lot of detail shortly. But let's say for time being that these tips work at different portions of the osteotomy, and this is why this is a wave system, because one tip, the delta 1 tip, will dilate the deeper bone, and the delta 2 tips will dilate the crestal bone. But this dilation is done in an overlapping progressive manner. Okay, we'll look at more of this detail shortly. So in this situation, we just have taken the zoom and zoomed in even further into the first 4 tips of the anterior kit. Again, we see the beautiful demarcations. We have the depth marks at 8, 10, 13, and 16. First 8 millimeters are threaded. And the other thing that I'd like to mention, we all know that a 3.7 diameter implant is very widely used for many of us. And what I have noticed in my experience using the Vgo system thus far is this. The 4th tip that you see here is sufficient in my hands and in my experience thus far to be really used well when we're planning to place a 3.7 diameter fixture. So in most of the cases I've done this far, the tip labeled number 3, which is the last one here, because again 0, 1, 2, and 3. So tip 3, which is the 4th tip, is typically been in my hands the one, it's the final one for a 3.7 implant, and I even recommend going slightly short of the full depth of your planned implant, and then try to finesse your fixture in. And if necessary, you can always widen the osteotomy a bit more, but I always like to err on the side of caution, meaning I rather make the final osteotomy a little smaller, where I have the option to expand it further as opposed to making it too big and having essentially a spinner implant, or a situation that I will have to be forced to put a fatter or wider diameter implant. I would like to just take your attention now for a moment to the apical portion of the osteotomes, and just to show what a nice convexity we have here. Okay, and then we have a beautifully threaded instrument and with very nice machined demarcations, which are also in addition laser marked. So let us now turn our attention to the posterior tips. And if you notice on the left side of the screen, the first tip here, which is tip number 1, is 1 millimeter, 3 millimeter diameter. So in essence, we are skipping the 1.0, 2.0 tip that we have in the anterior kit. So here, once again, the tips are from 1 through 8. And the starting point, the starting tip is a 1, 3. Okay. The next one is just like the anterior kit, 2, 3, 2, 4, 3, 4, 3, 5, 4, 5, 4, 6, 5, 6. And if you ladies and gentlemen observe now, we are starting to get this overlap in the tips. Okay. And this is the key to this formula and to the Vgo-Concept. So we have a stepped escalation of the tips, which is not linear, it's stepped, and this is the difference. If you also notice on the tips themselves, we have markings called S and I, S and I, S and I, and if you notice, they are dispersed on individual tips where necessary. Later in the presentation, you will understand that the tips marked S, I call that standard. The tips labeled with an I call those intermediary tips. So in essence, at any time, if you wish to use the system as a conventional osteotome system, you simply remove the tips that are labeled with the I. So you take out the intermediary tips and leave them aside, and now only use the tips labeled with the S on them. So now you will have traditional taper. So if you focus on the first one for a moment, we have 1, 3, and that's labeled S. If we go to the next one that's labeled S, then we have a 3, 4. So now essentially this becomes almost very similar to a standard escalation, 1, 3. So the base here is 3 on the first tip, and on the fourth tip, the apex is 3. So now essentially you're converting this kit into a standard kit. And this we'll look at in quite a bit of detail later on. Once again, if you observe on the bottom of the screen here, we have the delta dots, which we'll explain momentarily also in more detail. Each kit in the VGO system is equipped with 2 accessory tips. So we have a straight accessory tip, which is visible on the bottom of the screen, and we have on top of the screen an angulated accessory tip. Both of them are marked to the 8, 10, 13, and 16 millimeter marks, and they feature a precision machined, very sharp tip, which is used during immediate implant placement as a marking tip. And also this allows you to have precision pilot control if in case you'd like to re-angulate slightly your osteotomy. And I repeat, these tips are very useful whenever you extract an anterior tooth and you try to make the purchase point on the lingual wall somewhere between the mid portion and the apical area, so you can engage the lingual aspect. Well, very often the drill that we use with our motor-driven devices tends to slide down that cortical bone that lines the socket. So these tips become very useful for exactly that purpose. And once again, this was the reasoning behind why we incorporated them into the system. So let us focus now, and again, this is the same point I just made. we assume that we just extracted a tooth and we're doing immediate placement. Well, typically we very often like to engage the lingual aspect of that cortical socket, okay, which of course is pretty dense. So the green dot that you can see right at the tip of the drill is illustrating the typical purchase point that we'd like to create. And this is how we intend to use these tips for exactly this purpose. And also, as I said previously, for reangulation purposes, or for sometimes even for marking a particular spot. And once again here, we're just showing the typical trajectory that we like to follow during immediate placement. Sometimes when we have a lot of bone above the socket, we like to obliterate. And exactly which area we select for our purchase point largely depends on the shape of the available bone, on the thickness of the available bone, what's above the socket in question. So this purchase point marked in green can vary in location depending on the case, but in essence, with these tips, we feel that you will have a much easier time creating this purchase point and initiating the osteotomy. Here we're just showing the each handle, and one has the angulated tip placed, and we have a 20-degree angular change in the very apical portion of the tip. And we're showing on the right side of the screen just the straight marking tip. And of course, as I mentioned previously, we have the beautiful crossbar handle, which is very useful when rotating the instruments. So in order to appreciate the VGO system, we must stop for a moment and ask ourselves, do we only place 16mm length implants? And I think we will all agree that the answer is no. We place a variety of lengths of implants and a variety of diameters of implants. So for that reason, we have to have a system which allows us to have the ability to control the bony osteotomy for a variety of lengths of planned implant fixtures. So let us read what it says here on the right side of the screen. Implant lengths can vary usually from 8 to about 16mm with some give and take. So we need to have osteotomes that can accommodate properly variable lengths of implants that we potentially use. So osteotomes should be able to passively engage previously made osteotomies even when they're not used to the full depth of the working tip. So this is a very important point. And the VGO system, folks, accomplishes this goal for all implant lengths up to 8mm or longer. So now let us look at the Vgo-Concept at work. A couple of things to take a look at and focus on is how, why, where, and bone type. So let us look at how. We give you a choice. How you get there, how you treat each case, we give you a choice. Why? Because we offer you flexibility of use. Where? We're flexible with that also. Anterior and posterior, we address both areas that we very often work in. Bone types, well, we allow you to hybridize and treat different bone densities in a different way and in a different rate. So we essentially give you a choice that is able to be adapted to all bone densities. Some of the key points of the VGO system are below. So we can use these kits for bony expansion, for bony densification whenever we'd like to improve the bone quality from, let's say, a type 4 to a type 3 or even to a type 2. We can use it for immediate placement. We can do it, use it for ridge splitting, and certainly when we do crestosinus elevation. So in all cases, we're not removing bone. We are not generating any heat. And I have said this a few times, but I'll say it once again. This is very important, folks, because regardless of irrigation or no irrigation, whenever you're rotating at relatively decent speeds. You are rubbing, you are creating heat. So with the Vgo system, you also have very good tactile sensation and increased control and accuracy. Certainly less malleting in the posterior and no malleting in the anterior. We have passive osteotomy engagement, which is the entire concept of this whole system. Getting the osteotome to fit passively into the osteotomy without stressing the crestal portion of bone. This, of course, leads to a smaller or lesser chance of fracturing a buccal plate. When using the Vgo system, we first dilate the deep apical bone. That, in essence, makes the deep bone more flexible because each subsequent instrument will make the walls thinner. And then you expand the crestal portion. So once you thin out the deep bone, now the bone becomes more flexible. And now we open the crest. And this is done as a wave, back and forth, back and forth, back and forth. Tip activity begins at the magic number 8. Now this is progressive tip activity. But as you approach, as the threads disappear of the anterior kit, you will notice that the tactile sensation will change in your hands, and the instruments will literally almost begin to speak to you and tell you that they're starting to work. Pay close attention to the tactile feedback for these reasons. So what I'd like you guys to try to do when using these kits is to tailor your expansion rate. In other words, how fast you're dilating the bone. Tailor it according to the bone density in question. Whenever you're faced with cases with greater density, harder bone qualities, use the instrument slower. Okay? Whenever you have dense bone, remember slow. Soft bone, faster. This you have to think a bit and plan your cases, and also pay very close attention to the feedback that the instruments give you during the procedures. So what happens is, let's focus our attention on the left side of the screen, and we have a cross-sectional view of what typical bone morphology we find. And what happens is, with a typical osteotome, if you notice the red dots, a typical osteotome will start putting stress right here at the red dots. What we like to do is, we like to take where the green dots are, this area, and we like to think of it as being thinned out progressively, little by little, in the deep portion prior to spreading the plates apart. And this is the whole mechanism of the Vgo system. So we're moving this hinge axis of rotation into the deeper bone. So if we look at this diagram on the left, and let's think about it. So if we made dimension A thinner prior to attempting to spread crest of area B, then the deep bony portion would become more flexible. Wouldn't that be the case, guys? So let us focus on making the deep bone thinner first, before we attempt to spread the crestal portion B. And let's say it differently. If we made dimension A smaller, resulting bone will be thinner, and therefore it would be more conducive to flexing more. So traditional osteotomes, ladies and gentlemen, apply too much force at this very location, marked B. This often leads to the flaking off and cracking of the thin crestal area, and this is exactly what we need to avoid, guys. So here, if we look at diagram diagram on the left side of the screen, and the diagram on the right side of the screen, and we see what happens. We're starting out at point A, labeled point A on the left side, with a certain thickness of bone, and then we're gradually making that dimension marked A thinner. If we make this dimension marked A thinner, then theoretically this whole plate of bone will become more flexible. So this is just another illustration trying to drive the same point across. We'd like to stay away from the red dots. Okay, we'd like to move in the axis of rotation further into the deeper bone. We'd like to thin out the plates before we apply pressure laterally to expand them. So by making this area A smaller, we're making the plate more flexible. And then when we start to spread the crestal portion will rotate to the buccal and to the lingual with more ease. So as I previously mentioned, the variable geometry osteotomes, known as the VGO again, have a stepped tip escalation, which we see here. So we have an overlapping of the diameters of the tips, and this is what causes us to be able to work in this wave-like motion. Now we're going to start focusing our attention, ladies and gentlemen, to the actual tips. So the VGO system is composed of two types of tips, delta 1 tips and delta 2 tips. Okay, for the presentation, I like to think of delta 1 tips as being green and as delta 2 tips as being red. Why? Because delta 1 tips have half the taper of delta 2 tips. Okay, for that reason, delta 2 tips that are marked in red will work and dilate the bone twice as fast as delta 1 tips. That's why I like to mark them in red, so that whenever you're using and working with any one of the delta 2 tips, you use greater caution and use them a little bit slower than you utilize the delta 1 tips. So we're going to discuss more detail momentarily, but for time being, let's look at some of the major differences between delta 1 and delta 2 tips. So a delta 1 tip on the bottom left, if you subtract the base of the tip from the apex of the tip, rather the apex from the base, whatever tip you're using, you will always end up with a taper differential that equals to 1. So if you, for example, take the tip 0, which is a 1-2 tip, 2 minus 1 is equal to 1. So this means this is a delta 1 instrument. A delta 1 instrument will have an active apex. You need less caution, and all the tips that are even numbered are delta 1 tips. So in this system, folks, any tip that has an even number is a delta 1 tip. And all the tips have the delta dot above the instrument number. So if the tip is labeled, whatever number it is, the dot will be above the number. Above, on the upper left side of the screen, we have the delta 2 tip, marked in red because it's more aggressive. The taper differential between the apex and the base will always equal to 2. So if you forget, just look at the taper on the instrument, subtract the apex from the base, and see what number you have. If that number equals to 2, then you're dealing with a delta 2 instrument, and it has an active base, and it will dilate the crestal portion of bone, so you need to be more cautious. Any instrument that has an odd numbered tip is a delta 2 instrument, and the delta dot will be below the tip number. So let us again look at a delta 2 tip. So the delta 2 tip is red because it's more aggressive. The delta 2 tip has twice the taper of a delta 1 tip. So use delta tips more cautiously. Now let's read this. The marker dot placed below instrument number. Dot below instrument number signifies base being active. So whenever the delta dot is below the instrument number, you know, number one, that's a delta 2 instrument. You also now know that a delta 2 instrument will separate and dilate the crestal portion of the osteotomy and not do any work at the apical portion. On the other hand, a delta 1 tip, the marker dot is placed above the instrument number. And the dot above the instrument number signifies that the apex of the osteotome is active and the base will not do anything. So delta 1 tips, marked in green here for the presentation, will dilate the deep bone and will not do anything to the crest. And I also repeat one more time, delta 1 tips have 1/2 the taper when compared to delta 2 tips. So please, ladies and gentlemen, utilize delta 2 instruments always with greater caution because they work twice as fast. So let us turn our attention for a few minutes to tip number 1 from the posterior kit. So if we focus our attention on the right side of the screen for a moment, it says here that tip 1 is a delta 2 tip. Well, how do we calculate that? If we take, I have to actually correct this here, I realize I made a mistake. It should be 3.0 minus 1.0, which is the size of the tip. If you subtract 1 from 3, you end up with a number 2. So that in our system means that this is a delta 2 tip. So a delta 2 tip for all of our osteotome tips means that the tip will dilate progressively the crestal portion of the bone. Now, the next question we should ask ourselves is why, here if we focus in the middle of the screen, why over the number 1 we have a dot and we also have a dot below the number 1? Well, we assume that all of you out there will be using different implant systems with different pilot drills, and for that reason they will very likely vary in diameter. We know they will be small for the most part, however there will be some discrepancy between one surgeon and another. So for that reason we have marked our initial tip of the posterior kit, which is tip 1, with 2 dots indicating that you should expect this first tip to be fully active around the entire periphery of the tip. Because once again, you will be starting with an osteotomy that's presumably smaller than the first tip. And that osteotomy that you guys will be starting with will vary in size. So we assume once again that the first tip of the posterior kit will be fully active, and we have marked it as such. So we have marked it that it has an active apex and an active base. Okay, thanks. So once again here we're showing the posterior kit, tips numbers 1 through 8. And once again, if we focus on the left side of the screen and we look at tip number 1, again we see both dots. And here the top dot is indicated by green and the bottom dot is indicated by red. The reason I have selected red and green is because green indicates that we're dilating the safer bone, the deeper bone, the area where the bone is wider. So I indicated with green. So any tip that is indicated in green is called a delta 1 tip because the dot is above the number designation. So for that reason, all tips that have the dot above the number will dilate the deep, safe bone that's usually wider in width. And the same on the same token, if we look at the red indicated dots, they are below the tips. And this means that these are delta 2 instruments. They have twice the taper of the delta 1 instruments. And these instruments will dilate the thinner portion of the bone, namely the crestal portion. And I repeat, and I said this in many of my videos, whenever you're using delta 2 tips, you are dilating the bone twice as fast. You are doing the dilation from within, but the majority of the dilation will be done towards the crestal portion. So I urge all of you to utilize delta 2 tips with greater caution and also to utilize them slower, especially when you are dilating bone situations of type 1 or type 2 density, or rather dense bones. If the bone is softer, you can progress a bit faster. So here we're looking again at one of the key slides. And once again, if we look at example A, we have passive engagement, which in our opinion is the best. Then in the middle of the screen, we have passive active engagement, which is shown right here, where the osteotome meets the crestal portion of bone. It immediately starts to put force laterally. Okay, so we call that passive active engagement. This is a little bit of a review slide. And non-engagement, of course, is what occurs whenever we use a standard osteotome to less than full depth of its working tip portion. Then the subsequent instrument will start creating the scenario that you see in the right side of the screen labeled C, and that is called non-engagement, and that leads to crestal crushing and essentially affecting the crestal thin portion in a negative fashion. So let's go back to the left side of the screen here and focus on the bottom of the screen for a moment. It says the Zepf way. Well, the Zepf way, or the VGO way, essentially will provide the passive engagement for all osteotomy sizes up to the point where you reach the 8 mm mark. Okay, once you go less than 8 mm, then you start to have passive active engagement, which is still okay. So we are essentially providing you with this safer method of entering the osteotomy and dilating the bone that works essentially for all depths until you reach the 8 mm point. At which point, when you reach the 8 mm depth of osteotomies, then you start having the passive active engagement. But one thing to note is that whenever you're using the VGO mode, you are never coming into the zone on the right side of the screen, which is called non-engagement. So we don't even step into this zone. And this is the huge advantage of the VGO system. So let us look at this slide for a moment, and I'd like you guys to read the top portion, and I'd like you to read the bottom portion, and then I'll read it for you. So, dilation occurs over a given distance of active portion of tips. In our case, the total active portion is 16 millimeters. So our tips are again marked at on the posterior kit at 5, 8, 10, 13, and 16 millimeters. Okay, and delta 2 tips, if you look at carefully here, delta 2 tips are more aggressive tips because of greater taper differential over the given distance. Delta 1 tips, on the other hand, are less aggressive tips because of a lesser taper day feature over the given distance of the osteotome. Passive engagement shown for each subsequent instrument. So let us focus here on the left side of the screen for a moment. Let's look at the first instrument. So we have a 1-3 taper, and assuming that we work to a full depth of the tip, so we would have a residual osteotomy which has a diameter of 1.0 at the deep portion and 3.0 at the crestal portion. Now look what happens with the next instrument, right here, the second one. When that enters the hole left, think about it. We have a 2.0 tip going into an osteotomy that's a 3.0 diameter of the crest. So this tip, the second tip here on the screen, when it enters the hole left by the first tip, will enter completely passively. So this is the advantage of the system. So this is also very interesting here. The top says points of active engagement of subsequent instruments. As I said a few slides ago, I said that up until the 8 mm mark we have passive engagement, and after the 8 mm point it becomes passive active engagement. So let us again focus on the first two tips here on the left. When you drive the second tip into the osteotomy made by the first tip, the tip portion will start having a passive active relationship when it gets to the 8 mm point. but we are already how deep into the osteotomy. So this is what I've said over and over. This tip will become active when it reaches the 8mm point of the osteotomy. And this is a key factor that everyone must understand who plans on using the system. So in this slide, what I have done is I've taken the data from the previous two slides and superimposed it on each other. So here we're showing you the points of passive entrance into the osteotomy, which I just showed you a few moments ago. And I'm also showing you the points of active engagement of subsequent instruments. Let us take a look at the cross-sectional diameters at the 8mm mark. So the 8mm mark is the halfway mark on all of our tips, because the full working portion of our tips is 16mm. So at 8mm, if you notice, subsequent instruments escalate by 0.5 mm increment. So if you walk from the left side of the screen to the right side of the screen, you notice the cross-sectional diameter on the first tip at 8 is 2.0. The cross-sectional diameter of the second tip at 8mm is 2.5. The cross-sectional diameter of the third tip is 3.0, and so forth and so forth. Also, I'd like you to focus at the bottom of the screen for a moment, and we're just repeating what we said earlier. So tip 1 is a delta 2 tip, and we have it marked with a triangle that's red and with the number 2. How do we arrive to the number 2? Well, if we subtract 1 from 3, so 3 minus 1 equals to 2. So that makes it a delta 2 tip, labeled at the bottom of the screen as a 2. We have it also marked in red here for the benefit of understanding, and the red indicates caution because you're dilating the crestal portion. The crestal portion is usually the thin portion. Also, as I said previously, delta 2 instruments have twice the taper, work twice as fast, and dilate the bone at a faster rate than delta 1 instruments. So once again, we have them marked in red, so that this is an aid to help you understand the concept. If we move on to the second one, once again, we have it marked in green, because this instrument is dilating the deep portion, the wider portion, and the safer portion. We have it marked as 1 because 3 minus 2 equals to 1. So if you take the apex and subtract it from the base, once again you end up with the number 1. So this is indicative of a delta 1 instrument, and the safer instrument because it has 1/2 the taper of a delta 2 instrument. So let us take a look for a few minutes at the slide and ask ourselves what happens whenever we're doing an osteotomy that's only 8mm deep. Okay, so we're using if you look at the bottom middle of the screen, let's assume again we're doing only an 8mm osteotomy marked in yellow, and we are using all the instruments in sequence. So that means that we're using the Zepf Vgo mode. So now let us take our attention to the upper left corner of the screen and look at the first two instruments. So I have blocked off everything below the 8mm mark with blue. So that means that at the 8mm mark, when you use the first instrument, you will create a hole that has a taper of 1mm and 2mm. And 2mm, once again, is the cross-sectional diameter of the first instrument at the 8mm point. So the next instrument comes in and has a 2.0 apical diameter. So that means that at the 8mm point, this instrument will have passive active engagement, which is still okay to use. But this only occurs with the Vgo system once you get to that threshold of 8mm. Now let us look at the second instrument and the relationship it has with the third instrument. So if you see the cross-sectional diameter marked in red of the second instrument is 2.5 millimeters at the 8 millimeter point. So when the third instrument enters, it has a taper at the apex of 2.0, and the cross-sectional diameter of the second instrument is 2.5. So once again, even though we're dealing with an only 8 millimeter deep osteotomy, this instrument will still engage passively with the passive engagement type, the beneficial one. So in essence, what happens is, if you look now, if you take your attention to the bottom of the screen one more time, even when we're dealing with an osteotomy that will be only 8 millimeters deep, half of your instruments will have passive engagement, okay, the real good one, and the other half will have passive active engagement. So once again, 50% of the tips will have passive active engagement, and 50% of the tips will have passive engagement. So this is a huge benefit, because we're providing you a range of working anywhere from 16 to 8 millimeters, and you're still benefiting from the passive engagement. So here we have three main sections that we'd like to focus on. Section labeled 1, section labeled 2, section labeled 3. So let us look in order. So section 1 simply shows an osteotomy that's assumably made with a pilot drill. So we'll call this the initial osteotomy. We use a lance drill, an implant drill, a chisel, an osteotome, whatever you wish, but you made an initial hole. Then we show you in the portion labeled with the 2, we show you what a delta 1 tip action is like. And if you note the areas marked in green, we're showing you that the delta 1 tip will spread the deep bone. It will make the bone more flexible for the following tip. And this will create zero crestal stress, because this tip is not doing anything in the surface. Now if we move over to the right side of the screen, labeled 3, we see the action of delta 2 tips. So the delta 2 tips will spread the crestal bone, and the delta 2 tips will spread the bone now that is previously been made more flexible theoretically by the delta 1 instrument. And once again, folks, if you notice, the action of delta 2 tips are marked in red, because the action of the delta 2 tip is much more aggressive by a factor of 2 compared to the delta 1 tip marked in green. So let us take a look at again what happens starting from a pilot hole on the left side of the screen labeled 1, and then let's see what happens after that pilot hole has been acted upon by the delta 1 tip. Okay, so the delta 1 tip acting on the initial osteotomy will have crestal diameter unchanged, so we won't change the crestal diameter. Okay, so the delta 1 tip action, once again, to spread the deep bone and to make the deep bone more flexible by making its walls thinner for the subsequent instrument to follow. And again, the delta 1 tip will create zero crestal stress because it's not doing anything at the crest. So once again, we're starting with the pilot hole on the left. We act upon that hole with a delta 1 instrument in the middle, and then we get a net result which equals to, let's take a look. So the result is apex diameter increase, so the deep portion diameter we increase, so we're working the deep bone. The base diameter, which is essentially the crestal portion, remains unchanged. So once again here on the right side it says resulting apical bone is now more flexible. Well, let's think about that. We just dilated the internal portion by slightly making it wider at the internal portion. So theoretically that makes the buccal and lingual wall slightly thinner and therefore more conducive to flexing by the next instrument. let us take a look now what happens to the osteotomy that's residually left by the initial work that we just did with the delta 1 instrument, which is now essentially what we equal to in the previous slide is right here in the beginning. So we take that bone that's residually left following the action of a delta 1 instrument. That's the left side of the screen, labeled 3. Now we're going to act upon that with a delta 2 instrument, shown, labeled as number 4 here, and see what happens. So, once again, we take the initial left side here, and we act on it with a delta 2 tip. What will that do? It'll spread the crestal area. So use it with more caution, because the crest is usually thinner. The apex will remain unchanged. However, the base or the crestal portion will increase. Okay, so once again, 3 plus 4, the action of the delta 2 instrument. Where's the work being done? The work being done is marked in red, and it happens exactly the way the triangle marked in red shows, progressively. These instruments do not work, they don't jump from apex to base and apex to and base to apex. They rather progressively start to engage and dilate the bone in a sliding manner, which I'll show later. So what is the net result marked following the equal sign? We have the crestal portion dilates, and the apical portion, or the deep portion, marked with the number 5, does not dilate, it stays the same. I have previously mentioned that the variable geometry osteotomes have 3 main modes of activity, or 3 main modes of use. So we have the Zepf mode, which is the most beneficial, where you use all the instruments in sequence. And we also have the Zepf hybrid mode, where you will remove certain instruments that are marked a certain way, and then you will have the Zepf hybrid mode. Now, both the Zepf VGO mode and the hybrid mode will give you the engagement shown here, passive engagement. This is the benefit. Okay, if you further wish, for those of you who wish, you can use our system as conventional osteotomes by again omitting certain of the instruments, which we'll discuss later. However, the benefit of the hybrid and the Zepf modes are that in each parameter you're utilizing the tip escalation, where you're benefiting of not damaging your crestal area. Now we're going to spend a few minutes dissecting the differences between delta 1 tips and delta 2 tips. I have a couple of favorite slides in this presentation, and I think this is one of them. So here we show the difference, if you will, for delta 1 tips and for delta 2 tips, and how they compare to one another. So guys, ladies and gents, they are polar opposites to one another. Delta 2 tips, as I have mentioned on numerous occasions today, have twice the taper delta 1 tips. And they are polar opposites, meaning what? Meaning, think of salt and pepper. Think of men and women. Think of the North Pole and the South Pole. These are concepts that are in opposing forces to one another. Now, the men and women part, of course, is a little bit of a joke, so please don't anyone get offended. It's just for fun and to prove a point. Otherwise, we're all great, and no offense, please, anyone. So here, once again, I show the delta 1 tip action, how it acts in the deep bone, and on the right side of the screen we show in red the delta 2 tip and where it acts, namely on the surface bone or the crest. Now let us break down the differences between delta 1 tips and delta 2 tips just slightly more. So on the left side we see delta 1 tips. So all tips that are even numbered So even numbered tips, including tip 0, are delta 1 tips. So if you took one of your kits and took only the even numbered instruments, you end up with all the delta 1 tips at your fingertips. Again, delta 1 tips have an active apex. They're safer to use because they have a lesser or smaller taper differential of only 1 millimeter between the apical portion and the base portion of the instrument. And once again, they dilate the deep bone. On the right side of the screen, we see delta 2 tips, odd numbered tips. So if you took out all the tips that have an odd number on the actual demarcation for which tip it is, you end up having only the delta 2 tips. Once again, delta 2 tips have an active base, and you should always use them with greater caution because we have a taper differential of 2 millimeters between the apex and the base of each subsequent delta 2 instrument. And once again, we're working the crest. At the bottom of the screen, we're showing what happens to tip activity. So on the left side, we have, as you go from 0, I have it broken down into how much activity the tip is performing from a scale of 0 to 5. So on the left side, we see how we go from 0 to 5 in an increasing fashion. And on the right side of the screen, we see a delta 2 tip functioning how it's decreasing tip activity. So it's opposite. Okay. So when I had nothing better to do one day, I decided to take some sheets of balsa wood and paint them to illustrate the same point we have been discussing over the last few slides. So on top, we have delta 1 tips, even numbered tips. So if you look at my little models here, all the green ones are delta 1 tips. If you observe them compared to the orange ones, they have a lesser taper. So just by looking at these instruments, folks, after a while you develop a visual usefulness and memory that you will be able to recognize them only by looking at them. Because delta 1 tips, if you notice, have a smaller taper. The orange ones have a bigger taper. Okay, so once again, review. Delta 1 tips, even number tips. So tip 0, 2, 4, 6, these are delta 1 tips. Once again, 0, 2, 4, 6, even numbered, including 0, we have delta 1. On the bottom, same concept, delta 2 tips. Observe the greater taper on all 3 tips shown here. Observe odd numbers. So this is tip 1, tip 3, tip 5. Okay, odd number tips, delta 2 tips. Also, again, I repeat, the bigger taper differential. These guys will be working the crestal portion of bone. Use them with greater caution. You're doing the dilation at a rate that's 2 times greater than the green tips. And this is just another slide that shows the delta 1 tips and the mode of activity that occurs inside. At the bottom we have the delta 2 tips with the mode of activity occurring progressively as the red triangle shows. The dilation starts to occur at the crest. So distance D1 is bigger than distance D2. So let's focus upstairs on the left side for a moment. D1 here, this distance is bigger than distance 2. So we had initially distance 1, and then after the action of the delta 1 tip, we shortened that distance, and now it's distance 2 of the residual osteotomy left. So at D1, the bone is thicker and less flexible if you try to flex it and expand it. At the point labeled D2, the bone is now thinner and more flexible. Here for a moment, I'd like you, ladies and gentlemen, to focus on the different delta 1 and delta 2 tips and how the tip activity occurs progressively, as is marked with the areas in red. So the tip activity zones are shown And please observe how the tip activity progressively either increases or decreases. So how do we calculate the delta value? Let's say we don't know it. Let's say we really don't understand the system and we're just looking at the instruments and we're trying to figure out, make some sense of them. So let us focus how to calculate the delta value. On the upper right, number 1, base diameter minus apex diameter of that instrument will equal to the delta value. Number 2, the dot mark above or below the tip number is indicative of whether it's a delta 1 or a delta 2 instrument. If it's above the number, it's a delta 1. If it's below the number, it's a delta 2. Usually by visually observing the tip shape once you get used to looking at them. All odd number tips are delta 2 instruments, delta 2 tips. All even numbered tips are delta 1 tips. Delta 2 tips have more pronounced taper, so when you're just looking at them, after a while your eye will pick up the difference visually. Delta 1 tips have less pronounced taper. And in the same token, as I mentioned, the delta 2s is the opposite. They have greater taper, more pronounced taper. Let us further dissect the delta value and what it means. So delta means change. In our case, we mean a change from the tip base diameter and the tip apex diameter. To calculate the delta value, you simply subtract the apex diameter from a particular tip, of course, from the base diameter. So base minus apex equals your delta value. With our patented stepped formula and our current tapers introduced, the delta value will always be either a 1 or a 2. So folks, it will have a value of either 1 or 2. So the delta value is important since it tells the surgeon which portion of the tip is active and which portion is passive. This understanding allows the operator to know which portion of the osteotomy is being expanded at any given time. So in essence, all of our osteotomes are either a delta 1 instrument or a delta 2 instrument. So delta 1 tools dilate the deep bone away from the thin crest. Delta 1 tools have a smaller taper differential and are generally safer to use. A delta 1 instrument prepares the osteotomy for what the next instrument will do, namely to spread the crestal portion. Delta 2 instruments or tools dilate the crestal portion and should be used with much more caution. Delta 2 instruments also have a greater taper differential and therefore are generally more aggressive in the amount of work that they will do and where they will do the work. Let us focus our attention at the top of the slide for a few moments. So it says 2 is bigger than 1. It also says tip base diameter is bigger than tip apex diameter. So let's think about that. So 2 is greater than 1 and base is greater than apex. Therefore, whenever you see a delta 2 designation or you calculate a delta 2 designation, you should immediately think that 2 is bigger than 1 and that base is bigger than apex, and therefore this implies that 2 refers to the wider and fatter portion of the instrument, namely the base. And therefore the base is bigger than the apex, and therefore the base will dilate the crest. If we take our attention to the bottom of the screen, we again show how to calculate the delta values, and we again mark delta 2 tips in red because they have greater taper, because they will dilate the crestal portion, and because they should be used with more caution. On the same token, we have the delta 1 instruments designated in green to mean that they have less taper, they dilate the deep bone, and they also will work at a rate that's half as much as in comparison to delta 2 tips. So once again, if we focus on the middle left of the screen and we focus on instrument number 1, again we see at the bottom 3 minus 1, so base minus apex equals a 2. We call it a delta 2. If we look at instrument number 2 in the set, 3 minus 2 equals a delta value of 1. So this just simply explains to you how you subtract again the base, rather the apex from the base to calculate the delta value. And once again, the upper portions merely demonstrates the logic involved in just understanding the system. The VGO system functions in a wave motion type of tip activity. So in the middle of the slide here, we illustrate exactly this point of how the system functions as a wave. And before we focus on the wave, let us look at the middle portion of the screen where we have a blue dot at either above the designation of the instrument or below it. Once again, folks, these designations simply represent whether the instrument is a delta 1 or a delta 2 instrument. At the bottom of the screen, we're simply reviewing how we calculate the delta value, which we just covered, so I won't talk about that. So if we notice here, tip number 1 on the left side of the screen has 2 dots, one below and one above. And this is simply a review from a previous slide that this tip will be the initial tip used. So we have to assume that all users will be using pilot drills of variable diameters. And therefore, we assume and we designate our first tip in the system to be a fully active tip because we're assuming it will act on all walls created by the pilot hole. And the subsequent instruments, as you see, have the dot either below or above the instrument number designation. Also in the middle of the screen, we see some instrument tips are marked with an S and some are marked with an I. So with this system, if you chose to use it as a conventional osteotome system, then you simply will remove the instruments labeled with an I, which we call intermediary instruments, and you will simply use the instruments labeled with an S, which refers to the standard type of osteotome that most people are until now used to. So now let us look at the wave for 1 second. So we see that the first tip will start becoming active when the magic depth mark of 8 millimeters is reached, and it'll dilate the crestal portion. The next tip will function opposite to that and dilate the deep bone, and it will become also active when it reaches the 8 millimeter point. But what happens is the actual dilation starts to occur once the instrument is passively inserted to the 8 millimeter point, and then the instruments progressively start to become active. And this is a very important point to understand. So here once again we show delta 1 tips and delta 2 tips and how the tips become active. And the other thing I'd like to mention is, again, there's a logical and easy way to remember the tip activity, and it's the following. Delta 1 tips have consecutive numbers in the taper escalation. So, for example, it goes from a 2 to a 3. Right? Delta 2 tips, on the other hand, skip one number. So there is a jump in the taper escalation. So if you notice that you're using an instrument that says 1, 3, well, that's a skip. You're skipping the 2. So a 1, 3 automatically should mean to you, the skip should mean a delta 2. If there's no skip, it's consecutive, the instrument taper, then you're dealing with a delta 1 instrument. And in the middle of the screen here, we illustrate again in red and in green which portion of the tip becomes active at the 8 millimeter mark and how the tip activity progressively increases or decreases. And once again, we simply mention here that tip activity becomes active once the tip goes to the 8mm mark, or when the thread in the anterior kit goes below the bone. Okay, so the 8mm mark is what I call the magic mark. So this slide is rather important, I believe, for the reason that it shows that once the tips reach the 8mm mark and they become active, the tip activity now becomes progressively active for the full length of the tip, or as deep as you're going. So they become active at 8, and then progressively the tip becomes active to the full tip portion. As I have previously mentioned, the VGO system, or again known as the variable geometry osteotomes, is a very versatile system because we offer you 3 modes of use with several sub-modes of use. We offer you the ability to adapt the system to various bone densities and dilate or expand bridges based on bone density, depending on how fast or quickly you wish to go. And you accomplish this without generating any heat, and you also accomplish it without using a mallet in the anterior region of the mouth. And in the posterior region, we are using reduced amount of malleting due to the passive insertion of the instruments. And all this, ladies and gentlemen, will lead to less crestal stress, less bony destruction in the crest, and it will essentially give you a new tool to have available for certain cases. So now we're going to be looking at tip interaction, and I'm going to demonstrate as best as I can how the tips interact in relationship to one another. So let us focus now, assuming that we're starting with tip 1 from the posterior kit on the left side of the screen. So that's a 1mm and a 3mm taper. And again, on the left side, we show that the full working portion of the tips are 16mm. We also show that at the midpoint, which is the 8mm mark, that's the halfway mark, that's a cross-sectional diameter of 2.0mm. And let us look at now what happens when we have an osteotomy made by the first tip, and then what happens when the next instrument marked in green here, as we move towards the middle of the screen, will act onto this initial osteotomy. So again, we have a 1.0, 3.0 residual hole made, and now the tip comes in that has a 2.0, 3.0 taper, and let's see how that will actually affect the hole. So the highlighted in yellow, we'll be looking again at a delta 1 tip working onto a delta 2 osteotomy. And now if we move our attention to the right side of the screen, we start to see how the tip 2 approaches the hole, and then we see that it passively enters the hole in the middle of the screen on the right side, and then finally all the way on the right side of the screen we see when tip 2 starts to bind in the hole made by tip 1. Again, it happens at the magic 8mm mark, where the cross-sectional diameter is 2.0mm and the apical diameter of the subsequent instrument is a 2.0mm. So that's when the engagement occurs, and that's when the instrument starts to become progressively active. And once again, if we look at the corner of the bottom of the right side, it's passive engagement, folks. So this here on the right side is what passive engagement means once again. So shown here is a delta 1 tip working onto a delta 2 osteotomy. The tip becomes active for entire length when it reaches the 8mm cross-sectional diameter of the osteotomy. Delta 1 tip has progressive tip activation with most active portion at the apex, and this is marked graphically as 5, 4, 3, 2, 1, and gradually becomes 0 as you approach the tip base. So the delta 1 tip will only do work in deep bony area and will do 0 work in the thin crestal portion. So here we show tip number 3, which is a delta 2 tip, working onto a delta 1 osteotomy made by the previous tip number 2, which was a delta 1 tip. We once again have passive engagement, but things here happen in reverse in comparison to the previous slide or two that I showed. So if you focus here again, we have a residual hold made by the 2.0, 3.0 tip, which was tip 2 and a delta 1 tip, and now we're guys just focusing on the left side here of the screen. And then comes in tip number 3, which is marked in orange, and that's a delta 2 tip. And let us see when this tip starts to become active. So once again, highlighted in yellow, we have a delta 2 tip and how it works onto a delta 1 osteotomy. And if you focus now your attention again to the right side of the screen, you actually walk through the entire engagement process, and tip 3 starts to bind when it reaches the 8 millimeter point. Okay, so that's the engagement point. Once again, the 8 millimeter mark is the magic. Shown is tip number 3, which once again is a delta 2 tip, working onto a delta 1 osteotomy. Tip becomes active for the entire length when it reaches the 8 millimeter depth mark, at which point the cross-sectional diameter of the osteotomy is 3.0 millimeters. Delta 2 tip has progressive tip activation, with most active portion at the base, marked as 5, 4, 3, 2, 1. And gradually, activity becomes 0 as you approach the tip apex. So delta 2 tip will do only work in the crestal bony area and 0 work in the deep bony area. And once again, if we focus on the upper left, we see we're going from 5, 4, 3, 2, 1, 0. At this point, we're going to take our focus to the Vgo system and the modes of activity. So we have 3 modes of use. We have the Zepf Vgo mode, we have the Zepf hybrid mode, and we have the Zepf standard mode, which is the traditional way of using an osteotome. The Vgo and the hybrid modes both benefit from allowing you to have passive engagement. The Zepf standard mode resorts to using passive active engagement, and once again this occurs whenever you are utilizing the osteotome to the full working portion of the tip. If you begin to use it at less than full working portion, then we run into the problem of having non-engagement of the osteotomy, and this is the issue we're trying to avoid. So let us look at further detail in the following few slides. So the Vgo system offers flexibility. The Vgo-Concept as a whole offers 3 main modes. On the left side we have Zepf Vgo mode, we have on the bottom Zepf hybrid mode, and we have Zepf traditional mode. Now, the Zepf traditional mode can further be broken down into several modes of what I call sub-modes, where you can do your expansion either more quickly or more slowly, depending again on your bone density. And we'll look at further detail of this momentarily. And once again, let us review, ladies and gentlemen, on the bottom of the screen, both on left and right sides, that the Vgo osteotomes utilize a stepped tip escalation, and traditional osteotomes offer a linear tip escalation. Let us just remember that. So once again, ladies and gentlemen, we have 3 main modes of use. Zepf VGO mode, Zepf hybrid mode, Zepf standard mode. Zepf standard mode, once again, is further broken down into various submodes and possibilities. Now let us focus on the right side of the screen. And we say here that the Zepf VGO mode utilizes a stepped escalation with passive engagement. Now notice for the Zepf hybrid mode, we have linear escalation of the tips, but again with the benefit of passive engagement. And once again, when it comes to the standard mode of use, we have a linear escalation with passive active engagement that is passive active only when you're using the full tip portion of an osteotome, and this becomes non-engagement when you start working at less than full depth of the osteotome. When using the Zepf VGO mode, you essentially take each instrument in the sequence and use them one after the other. Tip 1, tip 2, tip 3, etc. Here once again we show you which tips are delta 1, delta 2. And we also mention that when using the Zepf VGO mode, we have the benefits of passive entrance into the osteotomy. We're utilizing a stepped tip escalation. We're once again using all the instruments in the sequence. And you can literally start at any point that you wish to start from, depending on where you are and what system you're using of the surgical tray from whatever manufacturer you choose to use. This is just a different way of looking at the VGO mode. And if we focus on the upper left side of the screen, we see that different portions of the osteotomy are being dilated at different times. Okay, so we see how our delta 1 tips will dilate the deep bony area progressively. And in the middle of the screen, as we move, we see how the delta 2 instruments will dilate rather the crestal portion. We also review once again that when using the Zepf VGO mode, we are using a stepped tip escalation and we are providing passive engagement of the osteotomy. If we take our attention to the low portion of the screen, we see that when we do an osteotomy of up to 8 millimeters, we are having passive engagement. When we go less than 8 millimeters, we start to have passive active engagement, which is still okay. But we're never treading into the territory of non-engagement, and this is the benefit. We are not using non-engagement, and therefore we are doing less crestal damage. Therefore we're essentially avoiding or minimizing the risk of fracturing the thin crestal portion. Now let us take a look at the Zepf hybrid mode. So if you wish to use the Zepf hybrid mode, you simply use all instruments that have odd numbered tips. All instruments that are odd numbered will be delta 2 tips. So to say it in a different way, if you only utilize the delta 2 tips of our system, then you will essentially be using the Zepf hybrid mode of expansion. Once again, we offer passive entrance into the osteotomy. However, the tip escalation now becomes linear escalation because certain tips have been omitted that are marked with the red X's. Tips are fully active for the entire length, and we have linear dilation. So we're pushing the walls out simultaneously, equally, in all directions at the same time. We're not doing, in comparison to the VGO mode, we are not doing the deep wave type of dilation. We're doing a linear dilation, which pushes all walls again equally out. And once again, we are omitting the tips marked with the red X's. And the tips marked with the red X's, if you guys look at the taper, you will realize that they are delta 1 tips. So once again, by leaving out all the delta 1 tips and utilizing only the delta 2 tips, you are essentially dilating your bony osteotomies as the Zepf hybrid mode. To look at the Zepf hybrid mode in a different scenario, or rather in a different manner, we again focus on the right side for a moment, and here we show you how all the bony walls are being expanded at the same time. Okay, so the bony walls are being displaced at the apex and the crest with a linear type of relationship. And if we focus on the actual left side going to the middle, we show, 4 of the tips. We show how we have passive entrance, and we also once again show that the tip becomes active when they reach the 8mm mark. We also show that the tips being used are all delta 2 tips. Also, as I mentioned earlier, we are using the odd numbered tips. So tip 1, tip 3, tip 5, tip 7. And this is once again the Zepf hybrid mode. All portions of the osteotomy are being dilated at the same time and at the same rate. The green arrows clearly show that the dilation occurring at the apex and at the base and in the middle of the osteotomy is essentially occurring simultaneously at the same amount. Once again, we only utilize delta 2 instruments with which we provide linear dilation. All right, so at the bottom we have again a graphical depiction which shows that all depths greater than or equal to 8mm, we have the passive engagement type relationship. Once we're equal to 8mm, the osteotomy then starts to have passive active type of engagement. And we're staying away from non-engagement unless we start working to less than 8mm. And finally, let us focus on the Zepf standard mode, which essentially allows you to use our system just like you would any other osteotomes that are currently in the market. So we omit or remove all the instruments marked with an I, which are the intermediary tips, and we are only utilizing the tips marked with the letter S, clearly circled with the red circles here. With the blue circles. So we're using this now as standard osteotomes, which means that we're using the standard kind of tip escalation that most of us have seen in the past. Ideally, you should be using this type of instrumentation when you plan on using the full and maximum tip portion of the instrument. This will assure that you avoid the non-engagement type relationship. And once again, if we just look at now the tapers in the instruments here, we have 1 going to 3 in the first instrument. So the next one starts at 3 and goes to 4. Next one goes from 4 and goes to 5. Next one is 5 to 6. So we are back to having the same kind of relationship where the base ends in one instrument is where the apex begins in the next. The base ends in one, the apex begins in the next. So this is again, folks, the traditional kind of taper. So now let us break down the Zepf standard mode further. So here I call the first mode of the standard mode, the sub mode, I call it mode S1, which means sub mode 1. So here once again we have completely traditional taper. We're going 1-3, then we're going 3-4, 4-5, 5-6. But what I'd like you guys to notice here, if we're using less than the full length of the instruments, then we start to have non-engagement. So this is, I guess, okay to use if you wish to use it this way, which I don't see the point of doing it any further, anymore. However, if you're using less than the full length, once again, people, you need to start understanding that the non-engagement will damage the bone. So we have traditional tip escalation, and dilation is done over 4 tips. So for this slide, just remember for a moment that we're going from point A to the end over a using 4 different tips. So here we're again doing the Zepf standard mode, which is the traditional way, and I call this mode submode S2. And here what's going on is we have the same final dilation occurring as it did in the previous slide. However, the dilation is done over a shorter overall distance. So dilation is done over 3 tips only in comparison to 4 tips in the previous slide. But the final end dilation is the same. So this mode is more aggressive than mode S1 because of the very reason that we're accomplishing the same end result over only 3 tips in comparison to 4. So therefore we're reaching our final destination, if you will, in a quicker fashion. So if you are dealing with soft bone, you can expand the bone faster since the bone is more elastic. So if you have a bony situation which is type 4, for example, and you wish to get to your final endpoint quicker, then it's okay to use the mode S2 in comparison to submode S1. Why? Because the bone is soft, so we can push it out a little faster. And here again we show submode S3. We're again reaching the same final destination, but here we start to have different escalations of the tips in terms of how they are being sandwiched in between each other. Now, if you choose to use submode S4, what you observe is that here the starting point is we're starting out with tip number 2, and we're only using delta 1 tips. So the dilation here, again, we're reaching the same final endpoint, and it's done over 4 instruments. And very similarly, submode S5 is very similar to submode S4. However, the dilation here is done over only 3 tips. So once again, when you're using only 3 tips in comparison to using 4 tips, the dilation will occur faster. So this is okay to do once again when the bone is softer. And I'd just like to point out once again here that the starting tip in this situation is tip number 2. And submode S6 once again demonstrates a different combination of the tips that is again using only 3 tips to reach the final destination. And once again, we are beginning here with tip 2. Here we show you a graphical depiction of the Zepf standard mode. Once again, we are utilizing the instruments marked with S. We are utilizing a linear tip escalation, which again is shown as the Zepf standard osteotomes. And this type of escalation is a non-overlapping escalation. And here the most important thing that again we must remember is this. What happens to passive engagement? Well, if we look at the bottom right side of the screen, it says at full depth. So if we're using the osteotomes at full depth of the tip, which is 16 millimeters in our case, we will provide passive active engagement. However, when we start working to less than full depth of the tips, then again we're running into non-engagement, and this is what we must avoid. So in summary, ladies and gentlemen, the Vgo system is a very versatile system that is much safer for the bone. It gives you many more options to work with. It will assure that you use less malleting in your patients, which your patients will love. And most importantly, I believe, is the passive entrance into the osteotomy, which is a huge benefit of the system. In using the system, I have made some observations on a personal note, and briefly here what I will do is just make some recommendations to any one of you that may consider using our system. So here's a few things that I'd like to discuss briefly. When you're using the system, feel what the instruments are doing. There's many cases that when I use them, I feel that they literally tell me what's happening. And I'd like you guys, you folks, when you're doing your cases with them, try to pay attention to what the instruments are doing and what they're telling you they're doing. Also, note that progressive tip activity begins at the magic mark of 8 millimeters. We also have spent quite a bit of time discussing the difference between delta 1 versus delta 2 tips. So when you pick up a tip, ask yourself which one is it, where is it going to work, and how much work is it going to do, and at what rate. Then you know that inherently the delta 2 tip should be used with greater caution. So which tip are you using? Always be aware. Which portion of the bone will the tip have effect on? You must ask yourself as well. So in essence, where, how much, how fast? These are all questions that you should be asking yourselves for every case. So once again, the tips become fully active when the thread disappears. The thread disappears at the end of the 8 millimeter mark. The other recommendation that I make is when you're taking the instruments out, try to unscrew them and try not to pull them out. Okay, let the thread disengage before you pull them out. Feel the jump. Tells you the thread has disengaged. So, when you're unscrewing a screw, once you start to come to the top of it, in the way we face in implant dentistry very often, you actually feel the screw as you keep turning it. After it's disengaged, it does a little bit of a jump in your fingers. So these instruments kind of have been giving me that type of feedback. So I'm just sharing it with you that it's something that you may consider to look for. Also, I recommend that you do not put excessive lateral forces on tip 0 because it's a very delicate tip with taper of 1 millimeter, 2 millimeters. So tip 0, as you guys know by now, is only found in the anterior kit of the VGO system. So it's a thin tip. Let's use it cautiously. And the other thing is, I would recommend not to leave the instruments unattended while working. So you may have an instrument in an osteotomy. I wouldn't walk away. Patient can move, they can fracture something, they can fracture a bony plate, and that's something that we would not want to see occur. So let us for a moment stop and think, if we were at a dental convention or if we were considering to purchase an osteotome kit, what would we look for? What can we get? So in this slide, I'd like to compare a standard kit and the Zepf VGO kits. The standard kit essentially will provide you one function of functionality, the standard mode, which we can also provide you. And the VGO kits, on the other hand, offer you 3 modes of use. We offer you the advances in the taper formulation that we've used, which essentially makes the progress of expanding and dilating safer and done in a different method. And we furthermore, if you do choose to use the standard mode, there's many submodes that you can particularly apply to different bone density situations. So clearly we do offer a tremendous amount of variation in functionality when we compare the VGO system to a standard osteotome set. There is one analogy that I'd love to give. I mean, if you're buying a car, so let's say that you have car A and car B. The same car, identical car, comes with one package option for X amount of dollars. Then you get the same car that comes with 10 package options for relatively speaking the same comparable price. So which one would you buy? Which one would you take? I think this does not need to be explained further. So as I said earlier in this presentation, I do have a few favorite slides, and this particular one happens to be one of them. Now again, I will claim that I've coined this terminology here, but if someone else has beat me to it, then again my apologies to them. But from the socket to the pocket, you know, there's two ways to go about this. You can go in a straight line and get there, you know, quickly, or you can kind of sometimes do things that are maybe not that quick, maybe take a little more effort and a little more time. However, it may be better for the patient and better for that particular situation. So I'd like to have you guys think about that for a moment, and let us all give it thought in the future. And ladies and gentlemen, finally, I would like to thank all of you for finding time in your busy schedules to dedicate the time that you have to join us for this presentation. So on behalf of myself and Helmut Zepf, we thank you for your time, and we hope to see you again in the very near future. Once again, thank you very much for joining us.